Hello guys, in this video we are going to discuss the solution of the problem insert in sorted way in a sorted DLL. So let us look at the problem statement. The problem statement says given a sorted doubly linked list and an element x, you need to insert the element x into the correct position in the sorted doubly linked list. For instance, if this is the doubly linked list which is given to us, and the value of x is equals to 9, then the correct position of 9 is after 8. After insertion, the doubly linked list will look something like this, and the head of the doubly linked list is what we need to return. So that's about the problem statement, folks. Now let us discuss the solution of this problem. So the general idea behind solving this problem is, first we need to find the position where the node has to be inserted, and once we have found out that position, we are going to insert a new node at that position. Now that position could be one of these three cases. First, it might be possible that we want to insert the new node at the beginning of the list, or it might be possible that we want to insert that new node towards the end of the list. And the third case is we want to insert node anywhere else in the list. So these are few points which we need to understand in order to solve this problem. Now let us take one point at a time and discuss it. So first let us see how we would be able to find the position where the node has to be inserted. So for that, let us take an example. So let us say this is the doubly linked list which is given to us, and the value of x is equals to 9. So as we can see, 9 has to be inserted somewhere over here. So first we need to find the position where 9 has to be inserted. So for that, all we have to do is we have to iterate on the doubly linked list while ptr data is less than x. So for this, what we are doing is we are going to take a ptr pointer, set it to head, and also we are going to take previous and we are going to set it to null. And then all we have to do is we have to iterate on ptr while ptr exists and ptr data is less than x. And in this body, all we have to do is we have to set previous is equals to ptr and ptr is equals to ptr dot next. Now if we run this logic on the example, then the loop will break when ptr is at this position. And what does this tell us? Well, this simply tells us that within this position between 8 and 10 we need to insert 9, and in this way we will be able to find the correct position at which a node has to be inserted. Now once we have found out the position where the node has to be inserted, let us look at each of these cases where we want to insert a node at the beginning of the list or at the end of the list or anywhere else in the list. So let us take each case at a time and discuss it. So let us discuss the first case where we want to insert the node at the beginning of the list. So for that, let us say this is the doubly linked list which is given to us, and the node which we want to insert is 0. So essentially we want to insert node at the beginning of the list. So for that, let us say there is an ptr variable which points to this position, and 0th node is something which we want to insert at this position. So let us say this is my 0th node and we want to insert at this position. Let us say this 0th node is given by new. So for this, all we have to do is we have to adjust the previous and next pointer of the node new and ptr. So let us do that. So new of next should be equals to ptr, and ptr dot previous should be equals to new. And since in this condition head has been manipulated, because of which what we are going to do is we are going to make head equals to new. So essentially what we have done is we have set this pointer, we have set this pointer, and we have adjusted head such that head points to this position. And then we are going to just return head. And in this way, we will be able to handle the case where the insertion has to happen at the beginning of the list. So let us discuss the case where the insertion has to happen at the end of the list. So let us say this is the doubly linked list which is given to us, and we want to insert 8 into this doubly linked list. So for this, the ptr will be at this position and 8 has to be inserted over here. Now the same thing we have to do, which is to manipulate the next and previous pointer of ptr and new. So what we have to do, ptr next should point to new, new previous should point to ptr. So let us do that. ptr next should point to new, and new previous should point to PTR. And in this way, we have inserted an element at the end of the list. Now let us discuss the final case where we want to insert node anywhere else. So let us say this is the doubly linked list which is given to us, and we want to insert 7 into this doubly linked list. So 7 should come somewhere over here. So for that, again we will have a PTR pointer. So the PTR pointer will be at this position, and then we are going to take a new pointer. So this is the new pointer, and new pointer is at this position. So again, what we are going to do over here is we are going to ensure that this next should point to this position. So let us do that. New next is equals to PTR next, and the previous of new should point to PTR. So new previous is equals to PTR, and the previous pointer of 8 should point to 7. So this connection. Let us do that. PTR dot next dot previous is equals to new, and finally PTR next should point to new. So let us do that. PTR dot next is equals to new, and in this way we will be able to insert a node. So that's the discussion of solution, folks. Now let us discuss the pseudocode of this problem. So let us say we want to insert a node into a sorted list. So first what we are going to do is we are going to get a node. So for that node of X, and then we are going to check whether this is an empty list. So if this is an empty list, all we have to do is we just have to return new. Otherwise, let us take a PTR and let us set PTR is equals to head, and let's take a previous, and previous let us set it to none. And then let us find the position where the node has to be inserted. So for that, while PTR and PTR data is less than X, all we have to do is we have to set previous is equals to PTR and PTR is equals to PTR dot next. Now if you recall from our earlier discussion, in order to find the position where the node has to be inserted, we were relying on this condition and we were getting PTR at this position. Please note, over here we want to insert node 9. So what we are going to do is we are going to ensure that PTR goes to this position. After this loop ends, we are going to check if PTR, then PTR is equals to PTR dot previous. Essentially, we are moving PTR to its previous position, and then we just have to insert the new node into PTR. So let us first discuss the case where we want to insert node at the beginning of the list. So for that, what will happen is PTR will be equals to null, so not PTR, and previous will also be equals to null and not previous. So if these two conditions are satisfied, then that simply means we want to insert node at the beginning of the list. And to insert the node at the beginning of the list, all we have to do is we just have to set new dot next equals to head, head dot previous is equals to new, and let us update our head. So head will be equals to new. Otherwise, it might be possible that we want to insert node at the end of the list. And if the node has to be inserted at the end of the list, the previous will be at the end of the list. And that is the reason why we are using previous over here. Otherwise, previous is not needed. So let us do that. Previous dot next is equals to new, new dot previous is equals to previous, and in this way we will be able to insert the node at the end of the list. Otherwise, let us insert the node elsewhere. So for that, all we have to do is new dot next is equals to PTR dot next, new dot previous is equals to PTR, and if PTR dot next, then next dot previous is equals to new, PTR dot next is equals to new. And in this way we will be able to insert a node, and towards the end we just have to return head. So that's the pseudocode, folks. Now let us see how we have implemented this in Python and C++. So first let us look at the Python implementation. So for that, new is equals to node, and if list is an empty list, we are returning new. Otherwise, PTR is equals to head and previous is equals to none. Then we are finding the position where the node has to be inserted using this loop, and then we are shifting PTR to its previous position. So folks, 1.2 note over here is, if let us say a node has to be inserted at the beginning of this list, in that case ptr will be equals to head and then ptr is equals to ptr.previous, because of which ptr will become equals to null. Now let us proceed forward. If the node has to be inserted at the beginning of this list, then in such case new.next equals to head, head.previous equals to new, and head equals to new. Otherwise, if node has to be inserted at the end of the list, then previous next equals to new and new previous equals to previous. Otherwise, new.next equals to ptr.next, new.previous equals to ptr, and if ptr next exists, then ptr.next.previous equals to new and ptr.next equals to new. And towards the end, we just have to return head. So that's our Python implementation, folks. Now let us submit our solution. So our Python solution got accepted. Now let us look at the C++ implementation. So the C++ implementation is also the same, folks. We got a node over here. If the list is empty, we are returning new. Otherwise, we are finding the position where node has to be inserted. After that, if the node has to be inserted at beginning of the list or end of the list or somewhere in middle. After insertion, we are just returning head. So that's the C++ implementation, folks. Now let us submit our solution. So our C++ implementation also got accepted. That is all from this video, folks. In case if you have any question or comment regarding this video, please feel free to use the comment section and I'll try to address them. Thank you.